Hello, this is lab 6. So I just wanted to start off by showing off my circuit. We've got our servo motor here, which is being wired up to this little wire connector here, which has this yellow wire connected to the green wire, which is reading our PWM into digital pin 8. The power is the red, which is going straight into the strip on the breadboard here, and the ground is black, which also goes straight into the ground strip here. Our Arduino is supplying the power to that power strip in the ground as well. And then this yellow wire here is going to be reading the value of the potentiometer from 0 to 1023. And then the red wire from the potentiometer is coming out here, which is supplying power to it, and this black wire is its ground. All right, so here we're just going to go over our basic code here. We have this top line. We're going to go line by line. So servo equals 8. So that's our digital pin 8 to be our servo output. And then this T period was given to us as 20,000 microseconds, which is just 20 milliseconds. Under void setup, we obviously just define our baud rate. We just pick 9600 bits per second. And we set our pin mode for our servo, which is this pin 8 to be an output, because that's what's going to be, actually being the physical output of this code. And then under the loop, we have this value that's going to be read by analog A0, which I talked about before. That's just the pin that's being read by the potentiometer. So it's going to read a value 0 to 1023. And then we have this T control here that we define as an integer, and we're using the map function, which basically says it's going to read this value read by A0. 0 to 1023. These are this is the range that it's originally from, and this is the range we want to remap it to, the 500 to 2400, which is the PWM range that we found on the data sheet for the SG90 servo. And then we have this angle. We're going to remap what we just got for the control period from 500 to 2400. We're going to remap that to -90 to 90 degrees, which is the angle of the servo that we want. And then down here, we turned our servo on, delayed it by the PWM period, then turned our motor off to make sure that the servo had enough time to complete its rotation. Then we delayed it again by that total period that we originally set minus the control period that we're reading from the potentiometer. And then I just have this little set of string codes here so we can see on our serial monitor when it's at its lowest point, it's at 500 and -90 degrees. And then off on the side here, when I turn the potentiometer, you can see that the period is going to increase and the angle is going to increase with it. So we're going to go all the way up to 2400, which is what I defined, and 90 degrees. All right, and after messing around with T control a little bit, our 500 to 2400 seconds was a little too long, and I was hearing a lot of the cracking sounds at the higher extreme. So I wanted to mess around with it a little bit, and then I got it to be a little too short. I went to about 900 to 2000 roughly. That didn't work, and then I found the optimal range to be 600 to 2300 microseconds. It goes the full 180 degrees, and we don't get any of those cracking sounds. So this is the low extreme here, and then you can see as we turn this potentiometer, we're also turning the servo, and then we get to max here and no reversing. Yeah, so I have full control over it just by changing this potentiometer. And yeah, that's all I got.